हरिः कन्ना।
Now let's look into advanced indexing and index tricks for ND array. NumPy offers more indexing facilities than regular Python sequences. In addition to indexing by integers and slices, as we saw before, arrays can be indexed by arrays of integers and arrays of booleans. So that we are going to see. So we will begin with arrays of integers and then we'll move forward for the arrays of booleans. So let's look into indexing with arrays of indices first. Arrays of, arrays of indices first. So in that, okay, let's begin with an example directly. Why to waste time? So it's advanced indexing and index tricks. So first one is indexing with arrays of indices. It's three. Yeah. So let me take A. That's NP A range and 12 range of 12. We are checking total 12 elements and each element should be exponentiated to 2. So the first two square numbers, so we'll be having the first two first 12 square numbers. Let me execute this and you see that you got all squares of each number. That is 12. The first 12 squares of number we got it. So then let me assign this to I. I is the another name, variable name, we have got it. And then NP array. This time I'm going to take array. And in this I'm going to take up a sequence of 1 comma 1 comma 3 comma 8 comma 5. So this is an array of indices. Okay, so now let me execute. So I made an array of indices. So let me check I. Yes, you got an array of indices. So now let me create a new array. J is np dot array. I have sequence of sequences. Sequence 1 and sequence 2. So sequence 1 consists of 3 comma 4 and sequence 2 consists of 9 comma 7. So this array is a bidimensional array of indices. So let me call J. So total A is main array. That's a squares array. It's a square numbers array. And I is indices array. J is bidimensional array of indices. So now what I'm gonna do is I will index A with bidimensional array of J. So let me type J and here is the values. You got that? So the same shape as J. So whatever shape the J has, the same shape we got. Let me, you see that 2 by 2 and now you got the 2 by 2. 2 rows and 2 columns. That's how we do indexing with array of indices. So when the indexed array A is multi-dimensional, a single array of indices refers to the first dimension of A. So now let's look into the one more example. So that shows actually the behavior by converting an image of labels into a color image using a palette. Let's see that. Let's take a palette. It's a computer vision based example. So the second example. So what here I'm going to take palette. So np.array, and I will have a sequence of sequences. So I will have 1, 2, 3, 4, 5 sequence we will have. So first sequence, second sequence, third sequence, and fourth sequence, and the last one, fifth sequence. So now let me add elements to each sequence. So the first one is 0, 0, 0. And the second sequence we have 255, 0, 0. And the third sequence, I think now you are able to figure it out what we are doing. It's RGB. So 25500, and it's a red, blue, RBG. Sorry, RGB, red, green, blue. So then 0, 255, 0. Then we have a 0, 255, 0. The third, oh sorry, that's done. So this I'm gonna have a 0, 0, 255. 0, 0, 255. Then the last one is all zeros again. 0, 0, 0. So that's my palette is ready. The first one is all zeros. It's a black. The second one is 255, 0, 0. It's a red. And then the third one 0, 255, 0, because it's a red, green, blue. Remaining are 0. It's a red. 0, 255, 0. It's a green. 0, 0, 255. It's a blue. And the last one I'll go with the 255. I want white. 255, 255, 255. Okay. Starts with 0, ends with white. Sorry, it starts with 0. That's a black, red, green, blue, and white. That is my palette. Let me execute it. So now let me call my palette and check what had happened. Yes, it's fine. Absolutely fine. Let me print the palette. Yes, you got it. A single matrix with a single matrix with 5 rows and 3 columns. Let me check the shape of it. So palette dot shape, it's 5 by 3. So then what I'm gonna do is, so I'll create an image variable name. I'll give an image variable name np.array, and this time I'm gonna add a sequence, one sequence. That's a 0, comma 1, comma 2, comma 0. So this the each value corresponds to a color in the palette. Here the each value corresponds to a color in the palette. So and I'm gonna add one more. This is 1. So let me add one more sequence to it. Yeah, let me add one more sequence to it. Yeah, done. So second sequence is 0, comma 3, comma 4, comma 0. So let me execute that. The second image, yeah, the size is 2 by 4. So now what we will do is we will index the palette from the image. Let's take palette and then image. We will be using image array as to image array as an indexing to the palette. Let me, so that 2, 4, 3. The 2, 4, 3 are the color image. So now let me execute it, and here is that you completely got a new array. So let me put this as a color image and execute it. Let me print the color image, and here is the value. So scroll down, let me print it and see how it looks. Yeah, absolutely, it consists of two matrices. Within that, it's a list of matrices. You see that? I just want to check the dimension. So color image and dim, the dimension is 3, and the size, I just want to check the shape. Color image shape, it's 2 4 3. It's a 3 dimension. You can clearly see 1 2 3. It's a 3 dimension. The first dimension, you have a two matrices, and the second one is each matrix has 4 rows, and each matrix has 3 columns. It's a clear cut 3 dimensional array. So now let's move back to the slides. So we can also give indexes for more than one dimension. So the arrays of indices for each dimension must have the same shape. That's the constraint. The constraint is that you have to be careful that the arrays of indices for each dimension uh, must have the same shape. So let's do that. Example 2 6, enter. So let me take a one more array. So np dot a range, and I want 12 elements in it. But what I'm gonna do is I'm gonna reshape it to 3 comma 4 size, 3 rows and 4 columns, and here is that. You can clearly see that. So then what I'm gonna do here is, so let me take a new array I. So I is equals to np dot array. So here I will have a sequence of sequences. So one sequence and two sequence. Total I'm going to have a 2 sequences here. So the first one is 0 comma 1, and the second sequence would be 1 comma 2. So total 2 sequences I'm having here. So this one, it's indices for the first dim of A. So our A has 2 dimensions, correct? Let me do that. Let me show it. So A dot n dim, execute it. It has 2 dimensions. You can clearly see. If still have doubt, what I'm gonna do is I'll call for that array's shape. So A dot shape, and here is that it's a 3 comma 4. There are only 2 dimensions, 1 and 2. Only 2 dimensions, 1 and 2. That's it, 2 dimensions. That's okay. And the I is indices for the first dimension. Let's take it as a row dimensions. Okay, for that dimension this is indices, and I'll take j np dot array, sorry, np dot array. And again this will also have a sequence of sequences. I'll have 2 sequences inside that. So this time I'm gonna write 2 comma 1, other one is 3 comma 3. Clear? So this one, and indices for the second dimension. So our array A has 2 dimensions, so we made 2 indices for respective dimensions. It's all done. Okay, so now let's use these 2 dimensions to index the array A. So A of, so dimension array array I and array J. So I and J must have equal shape. That's the constraint I have told you before also. So both has the same shape. So you see that 2 by 2 and then 2 by 2. Both have the same shape. Let me execute that, and here is that array has been indexed to exactly 2 by 2 on both the sides. On row side it's 2 and column side it's 2. Clear? So let me do a of I comma 2 and see how it works. Still it works. And let me do a of colon comma j. Oh, you got colon. I put the colon. So obviously rows, it will take the default one. That's a 3 rows. It has taken all 3. So now it has produced 3 dim. So let me check. Let me save this into indexed. Okay, indexed. So now let me execute it. So let me call indexed dot ndim, and you see that 3 dimensions. Let me check indexed dot shape, and clearly you should see three matrices and 2 columns, 2 rows and 2 rows each. So total, with a different kind of indexing, we can produce a different types of arrays. And next, in Python, ARR of I comma j is exactly, so ARR is just an array, a name of an array. An array of I comma j is exactly the same as array of I comma j, array of tuple of I comma j. So we can put I and j in a tuple and then do the indexing with that. That also works. It's not a big deal. So indexing with tuple. So let's take L. So let me take I comma j both as a tuple. And what's L? You see that? So L is nothing but an I comma j. So both the arrays, it consists of both the arrays. That's clear? So L is equivalent to A of I comma j. So now what I'm gonna do is A of L, and here is the value 2 comma 5 7 comma 11. So that's how we can use even a tuples to index it. In spite of directly using the values, you can index it. So I will do the same thing in another way. I'll use a tuple I comma j, and you see that you got the same value. Either you can use a direct value or you can use a tuple. So a of I comma j, you got the same value. So either you can directly use it like this or a tuple. It's all up to you to decide what you want. Next, however, we cannot do this by putting I and j into an array, because this array will be interpreted as indexing the first dimension of A. So that's what. You cannot directly put this into the array. So while indexing you can do that, but if you put into the array, so example for let me, so it may not work if you directly put into the array. I'll show that. Let me take a slice and then np dot array, and now inside that if I try to put I comma j, it gives some value, but this is not what we want. Clear? So now when I say a of s it doesn't work. Index 3 is out of bounds for access 0 with size 3. So that's what the problem. So if you want to index it, making an array and then use that array to index the main array A, it's not possible. So okay, in this way it is not possible. So in spite of that, what we can do is you just say A of tuple of S, and this works. This works. You see that? We took the same. Here we have assigned, we have converted, we have created a new array S, which is made up of I comma j. Okay, two arrays. Now if I directly use this new array S to index the array A, it has thrown an error. So in spite of that, in spite of directly using S, you can put that inside the tuple. You can do the typecasting of array to the tuple, and then you execute, you will get the value. If you remember the 25711, we got it in a previous results also. So that's how it's helpful. That's how the tuple will be useful for us. And another common use of indexing with arrays is the search of the maximum value of time independent series. Let's see that. So search of maximum value. Example. So let's take time this time as a variable name, an np dot linspace and 20 to 145. That's a huge number, and then 5 is step on. So now let me take the time scale. Okay, it's like our time scale. So now let me say time. Yeah, this is what we got. It's 5, 1, 2, 3, 4, 5. Total 5 elements we got, and it's in between. So 20 and 145. It's in between 20 and 145. Clear? Yeah. So now let me create one more variable, that's data. So np dot sign, the sine angle, a scientific notation, and np dot, I'll go with a range, and inside that I'll put 20 elements. I want 20 elements, and I'm gonna reshape it to what shape I'm gonna go with. Come reshape. I will go with the 5 comma 4. It's 5 comma 4, it's 20. Yeah, it's fine. So 5 comma 4, I'll go with the 5 comma 4, and so this is 4 time dependent series. Let me execute it, and let me check data what's there, and here is that 5 rows and 4 columns. 5 rows and 4 columns. Now we got a data also. So now what I want is I want to index of the maxima for each series. Index of the maxima for each series. That for that I'm gonna take a new variable called ind, and then data dot, directly I will apply argmax method to get the, so I want to run this through access is equals to 0. That's run through rows and execute it. So let me see ind, and here is that array of 22031. This is what the max values. Okay, so now let's get the times corresponding to that maxima. So times corresponding to the maxima. So time max, that's what the name I'm gonna give, and time of ind, because that's what we have done indexing. So now let me call time max and execute, and here is that those four. So we got the maximum values for that also. So and we all similarly we can do the data max. So data max variable, so data, and then inside that ind, and then a range I'm gonna go with is data dot shape of 1 and execute. So this is going to give me data max. Yeah, here is that. You got the values at the maximum values from the event data array. So now I just want to found the common, so np dot all. So data max double equals to the data dot, sorry, data max double is equals to data max. I just want to apply a method. I just want to compare the values whatever that I have got using this indexing is right or not using max method. Let me do that. Max, and across the axis, that's a row, axis equals to 0, and it's a true. I got a true, that means it's correct. True, I got it's correct. Okay, so let me look into the one more aspect. You can also use indexing with arrays as a target to assign to. So let me do that too. So indexing with arrays as a target to assign. So 6 and so let me check a. It's a simple np dot a range of 5 1d. I got a with 1d, then a of 1 comma 3 comma 4. So I just want to assign a 0 in that particular location. Sorry, the value was not inserted. Yeah, so now let me check the condition of a, and here is that. So using indexing you can even assign a value to particular targets. That's what I did here. You see that 1, at 1 the 0 has been added, at 3 the 0 has been added, at 4 the 0 has been added. The previous a array has been changed to the new way. Clear? So 1 0, at 1 0, at 3 0, at 4 is also 0 has been added. This is another way of using indexing. The next way, however, when the list of indices contains repetitions, the assignment is done several times, leaving behind the last value. So let's take the same example. A. So let me copy that, re-execute it, and I'll call it example 7 here. Oh, sorry. Okay, so A. Then what I'm gonna do is 0 comma 0 comma 2. So I'll try to assign 1 comma 2 comma 3. So direct a list of values I want to assign, and let me check what's going to happen. And this time, so it's been assigned for 0. One value has been assigned, and for another is 0, another value has been at 0. Two values has been assigned, that's 1 and 2, and another location at 2 the value 3 has been assigned. Rest all 3 comma 4 remains same. You see that? Let me see here. Okay, Clear? And the last one, uh, this is reasonable enough, but watch out if you want to use Python's plus equal to construct, as it may not do what you expect. So let me do that. Let me use that construct also. So example with construct, I'll go with 6. And so I'll use np dot a range of 5 elements and enter. So this time I'll use a sequence as 0 comma 0 comma 2, and I just want to assign a list, no, directly I just want to do uh, an operation that's plus equal to 1, and let me execute that and call a. So 1 has been added at 0 location, 1 has been added at 0 location, 3 because at this position we have 2, so that's why. Okay, but before that, what I'm gonna do, I'll call a here. So let me execute this. Okay, this is what my a. And now let's compare. So 1 has been added to the 0, and 1 has been added, but this hasn't been changed. 1 has been added to this 2 3, but because see, that's what 0, we gave 0, and another index is 2. So 2 is this, at 2 also it's been added. So wherever we have mentioned, at that places the 1 has been added successfully. So even though 0 occurs twice in the list of indices, the 0th element is only incremented once. I am going to show you one more time. So here if you see, 0 has come twice in the indices, a list of indices. The 0th element is only incremented once in the result. So this is because Python requires a plus equal to 1 to be equivalent to a is equals to a plus 1 operation.